All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna carry on learning about OpenCV's basics, basically where we left off in the last stream. I'm gonna spend today's stream mostly learning, or well, relearning the basics of OpenCV, just so I can apply that knowledge in Mediapipe later on. Though looking at some of the code, some of the example code in Mediapipe, it doesn't seem like I need to worry too much about OpenCV's basics. But I still want to familiarize myself, or well, re-familiarize myself with the basics, just so in case if I have any any situations where I have to use OpenCV functions, I'm not stuck. I still don't know if. Well, okay, let's take a look at the. So this is the code for detecting pose in an image. This code, it's got two parts. One is the visualization method, the visualization function that you create, and the other is running inference on the model to detect the pose on the image. And in most of these, it seems like Mediapipe provides its own methods for doing various things. Though, okay, what about this? I am show image. Okay, so it might be using Mediapipe's method of showing items. I'm guessing it's going to be the same thing for. Okay, let's take a look here. Let's see. Wait, no, not here. Was it here, I think? No, it might have been here. Why is this so zoomed in all of a sudden? I didn't zoom in. Did I zoom in? I don't think I did. Alright, anyways. So, actually no, did I zoom in? I think I might have zoomed in. Yeah, I think I did zoom in. Okay, anyways. So the example here, there's three examples. So you can look at the example using images, then video, and live stream. And in each of them, they are suggesting that you use OpenCV's. Well, they're saying you can use OpenCV's method of getting, for example, getting the video capture device. OpenCV allows you to do that if you wish to do so. And yeah, that's one of the reasons why I kind of wanted to just refresh my knowledge of OpenCV, because I looked into these topics. Okay, so these are the three topics that I kind of want to go over. And that's it. I'm not going to go any further in terms of OpenCV, because I don't need any of the other stuff, to be honest. I'm mainly concerned with this. Like, this is the basic stuff that I need. Working with images, working with videos. Video can be recorded videos, or even a live feed, such as a webcam. And then you have simple drawing functions, stuff like drawing lines and various primitive shapes, and also text. You can write text here and there on, like, basically anywhere on. I believe your limit is the image. I think so. I don't remember. I think the limit is the image. So yeah, I wanna just go over these. Let's see if we're able to finish it in this stream. Prior to starting the stream, and actually even in the previous stream, we looked into OpenCV, and we looked into the image handling side quite a bit. Even off stream, like after I finished that stream, I kept on reading up on this, and I've kind of familiarized myself with these methods. I was also working on just refreshing my knowledge of NumPy arrays, because I haven't touched it in a while, so I kind of needed to just refresh that knowledge and be able to do various things in it. Like, for example, I don't know, being able to access elements, being able to just visualize in my head what exactly a 3-dimensional or 2-dimensional array would look like, or more importantly, how I would be accessing them and what their shape is going to look like from the Python point of view and stuff like that, various things. So yeah, I think we are pretty much done with this. I don't need to go any further with this. So I recorded a video. I cannot play the video. I cannot play the video on stream right now because it's not gonna be picked up by OBS, because I'm not doing a desktop capture. I'm doing like window capture, and actually just I'm doing multiple window captures, so it's not gonna be picked up. But it doesn't matter. Like the whole idea is I recorded this video so that I can then play this back using OpenCV. So that's what I'm gonna be trying to do. Okay, so getting started with videos. Let's start with this. Okay, this is going into capturing from the camera. We are not gonna do this right now. We will look into video capture or webcam capture later on. I've already done this before, actually. Like I said, I'm basically refreshing my knowledge of OpenCV. I have messed around with OpenCV before. Mainly what I messed around with was the video capture, because I wanted to see if I can get how easy or hard would it be to get webcam capture in Python. And it turns out if you have OpenCV installed, it's literally just a few lines of code, and you can have the webcam, you can get the webcam feed and show it in a window as if it were some native webcam application. And that's pretty great, dude. That's not only that, I believe you can also control the frame rate at which it gets displayed. I think so. I don't remember. No, I think so. Yeah. Oh, also another good thing is you're not limited to just that. I believe you can also save that. You can also save, like, you can gather a couple of frames and then save the video, which is super convenient. So you can do all of these like basic operations with OpenCV if you are looking to just like capture webcam feed for any purpose, for any reason. In my case, it's to do Mediapipe stuff, right? But if you're looking to capture your webcam feed for any reason, and then send that feed somewhere else, like send it over the network, for example, you can do that very easily using OpenCV. In fact, something I had in mind, like an idea I wanted to try and implement, like I wanted to see how well or not well it would work. I wanted to see how well it would work out if I would capture webcam frames using Python, using OpenCV on one system, and then send those frames over the network to another system and then display them there. I wanted to see like how much latency I would be dealing with, because I'm guessing there's definitely going to be some latency, and at that point I'm gonna have to involve some kind of codec And at that point, I kind of have to find ways to optimize it. I need to find ways to compress the data that's being sent, but I need to do something a little more sophisticated than just compressing every single frame before sending it. I need to be able to use a codec. The good thing with codecs is they do a little more than just compressing every single individual frame. Especially video codecs, like they've found clever ways of packing information from multiple frames into, well, not into one frame, but like packing information from multiple frames in such a way that the information becomes much smaller than, let's say, if you were sending each of the frames by themselves. So yeah, I wanna try and implement something like that. I need to see how well that would work. If, like, I don't know how. I'm sure there might be some. I'm sure there might be some codec out there that is, or probably a bunch of codecs out there for sending video feed over a network. So I can try and use one of those codecs eventually when the time comes. But yeah, that's one of the many ideas I have. Okay, for now we're gonna read through this section, but we are mainly gonna be looking at like playing video from file and saving video. We'll practice the capture video from camera a little later, not now, because I don't wanna hook up the webcam to. Actually, I think I'll do that off stream. Yeah, I think I'll do that off stream. The webcam thing. For now, I do have this video, so I can. Yeah, I think there's important information here in this section, even though I won't be doing it right now. There is some important information that I can use. Give me a second. Let me hydrate and then we can start reading. All right. So often we have to capture live stream with a camera. OpenCV provides a very simple interface to do this. Let's capture a video from the camera. I'm using the built-in webcam on my laptop. Convert it into grayscale and display it. Just a simple task to get started. To capture a video, you need to create a video capture object. Its argument can be either the device index or the name of a video file. Okay, hold on. Its argument can be either the device index or the name of a video file. Okay, that makes sense. So if we give it an index, it's going to look for devices. If we give it the name of the file, then it's going to look for the file. A device index is just a number. It's just a number to specify which camera. Normally, one camera will be connected, as in my case. So simply pass 0 or -1. You can select the you can select the second camera by passing 1 and so on. After that, you can capture frame by frame. But at the end, don't forget to release the capture. Okay, so we create the capture device. Okay. Well, we don't create the capture device. We create the video capture object. All right. And then we check if object.isOpen. If it is false, then, oh shit, dude, I completely forgot that this was a thing. Well, I didn't exactly forget. Funny thing, just a second. I just realized that I have two instances of MS Paint open. One is Paint 3D and the other is just your legacy MS Paint. I don't know if they're somehow taking up some space or taking up some resources. So let me just close them. Also, give me a second. Okay. Great. So, yeah, I use this a lot when I'm using the Python interpreter, as in not creating Python modules and trying to run them through the command line, but rather using the Python interpreter itself, in which you enter, line by line of code. So like to exit that, you have to use the exit command. But outside of that, it just never occurs to me to use the exit command. I think part of the reason there might be that I'm usually not trying to exit out of a program. The idea is to get to the end of the program, at least like in most of the scenarios that I've been in. And there's been a few scenarios where I had to exit out of the program, but like not that often, because usually it gets handled in some way or the other. Like the exiting gets handled in some way or the other. Anyways, okay. So if the device was not able to be opened, then we will exit from the program. If not, or well, if the device was able to be opened, then we start this loop, and in the loop we are reading from the device, and that returns ret and frame. So what does cap.read return exactly? Let's find out. Okay, so there's cv.video capture. We'll open that up. Cap.open. Wait, did we use cap.open here? Cap.open is not used. Okay, let's open it up anyway. So cap.open. Wait, you can check whether it is initialized or not using the... Oh, okay, that's when you use cap.open. Okay. Where is the read function? I'm not seeing it mentioned anywhere here. Did I miss it? I'm not seeing it anywhere here. Video capture. What does video capture return? Well, I mean, it maybe video. Well, yeah, okay. Video capture is the object, right? So this will have the function. Public member functions. Okay. Open, read. There you go. So that's what I'm looking for. Grabs, decodes, and returns the next video frame. Now, exactly what does this return? This returns ret val and image. Image is our frame. Ret, what is ret val supposed to be? Let's read that. Returns false if no frame has been grabbed. Okay. Otherwise, it returns this tuple. The method slash function combines grab and retrieve in one call. This is the most convenient method for reading video files or capturing data from decode, and returns the just grabbed frame if no frames has been grabbed. That is, if the camera is disconnected or there are no more frames in the video file. The method returns false. Would ret val be... Oh, hold on. Let's go back to that code real quick. Okay, if not... Yeah, if frame is read correctly, ret is true. Okay, so as long as ret val is true, we can assume that there is a frame to read. And when ret val is false, then we just assume that we are out of frames, meaning it's the end of the video, right? If no frame has been grabbed, okay, the method returns false and the function returns an empty image. Okay, all right, now I get it. Okay, so that's what it's. So frame contains our image, which would be, I'm guessing, a mat, a CV mat, and then retval is going to contain, it's going to tell us whether there is a frame to read or not. Now, if there's no frame, then we exit, okay. But if there is a frame, then we carry on reading, and there is, okay, so OpenCV has some operations that let you transform an image in certain ways. It has a few options. I don't remember it being a very long list of things that you could do, but grayscale was definitely one of them. Does it have it here? BGR to gray. Yeah, okay. Grayscale was one of them. So okay, this converts an image from one color space to another. Okay, that's interesting. So grayscale is being considered a color space here. The function converts an input image from one color space to another. In case of a transformation to from RGB color space, the order of the channels should be specified explicitly, RGB or BGR. Note that the default color format in OpenCV is often referred to as RGB, but it is actually BGR. The bytes are reversed. Okay, so... Oh, you know, I think I also noticed this. Well, okay, no, that's not entirely true. Yeah, no. Now that I think about it, no, that's... Okay, so what I was just about to say is because earlier I made this little image. I don't know if VS Code will let me view the image. Actually, I could just have it displayed here. I can also resize the window, make it big enough, and wait. Okay. So let me try to display this image. Hold on, is there any other code? No, that's it. Okay. I don't know if the video resizing is gonna stretch the image or not. Let's see if it does, because it's otherwise it's a 16 pixel image. It's a 4x4 image, which isn't gonna look that big unless it decides to stretch it. I don't think it's gonna stretch it though. If it's fine, if it doesn't, I can just open it up separately and show it. But basically, oh, wait a second. Something is going on here. Test window. Oh, okay, the thing did show up, but it's too small to see. How do I show this? Oh, you know what I could do? Actually, no, I don't want to do that. I don't know how that's gonna... Can I zoom into this specific image? Oh no, it's zooming into the entire thing. Crap. Don't do that. Let's go back. Is this what I was at? No. I think this is what I was at. Now. Okay, so I can control the zoom for... Okay, good. Wait, can I give like a higher level? Does that work? No, that doesn't work. Okay, 1,000. You guys can still see it. So this is a 4x4 image, and in this image there's supposed to be more colors here. Why are the colors not showing up? I made some changes earlier, and did I forget to hit save on the image? I guess I did. Okay, anyway, so I did red, green, blue, magenta, cyan, yellow, white, black, gray, and then I'd done 3 more colors here, which were like different combinations of like half values in R, G, and B, half values and full values in R, G, and B, just to get some extra colors. So I could then read this image, because I know the size of this image, right? I could then read the image using this, basically, because this image gets loaded as a 3-dimensional array. So it's an array of arrays of arrays. The size, or the shape, not the size, the shape of the array is shown here as well. So let me, okay, so whatever is displayed doesn't matter, but yeah, this is the data. This is the array's value. You have on the top, you have the 4 white rows, the 4 white cells, and then below that you have the other colors, and then below that you have the other colors, and at the bottom you can see the colors that I had set up. You have BGR, so you have to keep that in mind. So that's why this is red. This may, if you look at it from a point of view of RGB, then it might look like blue, but like I believe, yeah, I believe it's well, it would be kind of silly for it to be displayed in RGB, but it's still being treated as BGR. That would be kind of like confusing, right? So if it's treating it as BGR, then I believe it'll also be showing BGR. So this would then be red, this would be green, and this would be blue, and then this would be magenta. And yeah, this is the shape. I forgot why I was telling you that I had done this earlier, but yeah, I made this image just so I could, like, pick specific pixels. And oh, another thing I could do is I could change one of the pixels, and then we could see what that looks like. So let's say I change, I think it's I am right. So what am I trying to change here? I'm trying to change the very top, which is white, right? So I want to change, I guess I start at 0 then, right? 0. Let's do the leftmost. So first row, first column, and first element. No, first row. I think looking at it as row kind of messes things up. Because I need to look at it as, I mean, technically it is a row, but like I need to look at it as an array. The first row is an array. Within that row, we have an element. Wait. So first row, first element, and this. Oh, okay. All right. So first row, first element. I need to give it a BGR value. So let's say I want to make it, what does blue and green give? Cyan? I can't remember right now, but yeah, okay. So this would be BGR, blue and green would be full. Okay, so after that we can do I am, what was the method? I am right. I'm right. Color pal o2.png, and then we pass in img. Great. So now we run this. Okay, that created the thing. And let's set the zoom level. Okay, so you can see cyan has been shown here. This is understand this is a very small image, so I think that's one of the reasons why it's having a hard time really zooming in, because we are literally looking at like 16 pixels in total. And I kind of did that on purpose because like that way I could hit specific pixels and see the result. But yeah, okay, cool. So let's go back to reading this thing. Where were we? I was looking at, okay, so this was the color conversion thing. Okay, there's an ad playing, so I'm gonna, oh shit, it's also time to hydrate. So I'm gonna hydrate and wait for the ad to finish. Welcome back. Okay, so yeah, this method converts between various color spaces, and one of the color spaces is apparently grayscale. I never actually looked at it as a color space, which it's kind of interesting to look at it from that angle, because like it's also interesting seeing seeing various grayscale algorithms. There are actually a couple of different ones, and each one gives you varying results. I also noticed something a while back. I made a color changer shader in Unity that allows you to change colors of. It allows you to do color changing operations on whatever textures you have. So you can like swap out colors. You can do arithmetic operations on colors. You can like remove colors. There's various things that you can do. And with certain operations, I noticed that I was able to get grayscale results. The interesting thing was I was able to get 3 different grayscale results. Give me a second. So yeah, the interesting thing was that I was able to get multiple grayscale results, 3 different grayscale results, and it was interesting seeing how each one of them varied. Each of them had like their own appeal to them, which is kind of interesting. It's kind of, I guess it sounds kind of weird saying that about a grayscale image, but like, dude, grayscale has its own sort of appeal. And I noticed a lot of these things when I made that color changer shader, which, by the way, just shameless plug. If you want to go visit the world that I made, this was a couple years ago. It's a world called Colors Around You in VRChat. And among other things, that world also showcases my color changer shader. There's a UI panel where you can change colors of various things, and there's like a whole bunch of colors going on in the world. So when you change values in that UI panel, you're definitely going to see changes happening. Okay, now back to this. Did I click on, okay, color conversion codes? Wait, did I click on that or no? I don't think I did. I don't think I did. Okay. All right. Color conversion code. So this is an enum. Yeah. Okay. This is an enum. So BGR to BGRA. Okay. So this involves alpha. Okay. Remove alpha. Convert RGB and BGR color spaces. Okay. Convert between BGR or RGB and grayscale. Okay, there you go. So that's BGR to gray. Okay. Convert between BGR and BGR 565, 16-bit images. Okay. Wait, 16-bit images. When we say 16-bit, like, okay, if we talk about the colors, because like what we are currently looking at would be 32-bit, I guess, right? Because each channel is 8 bits. So R, G, B, and A, that's, 8 times 4. So that gives you 32, I think. Yeah, yeah. That gives you 32. So that would make our images 32-bit. Okay. All right. What else do they have? Convert between grayscale and so and so. And then they have to XYZ. Okay, then there's Luma Chroma and HSV. I'm guessing there's also going to be, what was the other one called? CYM, I think, for cyan, yellow, magenta. But it's good that it provides you an HSV option as well. That's very useful. I don't know why I'm going through this entire thing. I'm just super interested in like what all it provides you with. Okay, then there's hue, lightness, saturation. I don't think I've looked at that color space. I've seen hue, saturation, value. Does this have something to do with HDR maybe? Okay, carrying on. Okay. YUV. Okay, I don't think I've ever seen YUV. Hold on, let me Google this. Actually, let me Google each one of them. So let's look at Luma Chroma. In video, Luma represents the brightness of an image. Hold on. Let me open that up. Oh, in video, Luma represents the brightness of an image. That is black and white or achromatic portion of the image. Luma is typically paired with chrominance. Luma represents the achromatic image, while the chroma component represents the color information. Represents the achromatic image. Oh, achromatic as in grayscale image. Okay, and then chroma represents the color information. That's interesting. That's an interesting way of looking at it. Holy shit, dude. Wait, so by that logic, if I wanted to get the grayscale value, wait, so okay, how is this represented? Because like achromatic, if it's grayscale, you only need one channel, right? You don't need multiple channels there. And then the color would then represent the other 3 channels. What is this represented as? Hold on, maybe I should open this up here. Give me a second. I'm just gonna open this up here real quick. Oh shit, I forgot to open up my VTubing app. I just realized that. Also, is the music still going? No, the music stopped at some point. So let's just fix that as well. All right, give me a second while I open up, or well, while the app opens up. All right. Oh shit, everything just went black. Oh, okay, there we go. Oh, I think it was the spout capture that did that. Okay, okay. All right, so we are reading this. Converting RGB sources into luma and chroma allows for chroma subsampling because human vision has finer spatial sensitivity to luminance differences than chromatic differences. Wait, luma is the black and white portion, right? Luma represents the achromatic image. I've never heard the word achromatic, so that was interesting to me. Let's just get like a proper idea of this. Gray, or well, okay, it leads to gray. It just leads to the page gray, the page of the gray color. So I'm gonna take that to mean that an achromatic image basically means grayscale or black and white. What does chroma mean exactly? Let's just look at the definition of chroma. The purity of a color. Oh, that's it. I've never heard it put in that way. The purity of a color. All right. Achromatic. What does that mean? Achromatic, as in without color, meaning black and white. Relating to using or denoting lenses that transmit light without separating it into constituent colors. Okay. All right, so luma represents the achromatic image. So basically, if I'm ever able to get an image, if I'm ever able to convert an image between RGB and luma chroma, I would then be able to wait. Is that what it's called, or is it just called that in this enum here? Where's that list? It said luma chroma somewhere here. Yeah, there it is. AKA YCC. Okay, RGB values of example colors with the same relative luminance as the lightest primary color green, using NTSC primaries for something. Okay. Where does Y, U, and V come in here? Okay, give me a second. Luma YCC. YCBCR is used to separate. My god, why did this become loud all of a sudden? Okay. So let's open this up. Chroma subsampling. Chroma subsampling is a practice of encoding images by implementing less resolution for chroma information than for luma information. Okay, hold on. Luma YCC. Okay. All right, so I think yeah, I think this is so YCC is the color space here. Okay. We can transition back. My god. Give me a second. All right. Much better. Okay. So, YCBCR and whatever other alternate pronunciations are there is a family of color spaces used as part of the color image pipeline in video and digital photography systems. Y is the Luma component, which is the black and white component, and CB and CR are the blue difference and red difference chroma components. Blue difference and red difference. Where does green come in there? Y with prime is distinguished from Y, which is luminance, meaning that light intensity is non-linearly encoded based on gamma corrected RGB primaries. Okay, okay, wow, okay, this doesn't flow off the tongue easily. Hold on, dude. Okay, the CB-CR plane at constant luma 0.5. Okay, this is, oh, dude, this is really interesting. I want to explore this color space more, because I haven't really messed around with any other color spaces outside of RGB and HSV, and in the rare cases like OpenCV, BGR, which BGR isn't necessarily a different color space, it's just swizzling, like you've just swapped the values. It's just a different way of representing that same color. Do we have a list of color spaces here? Examples, conversion, lists. Generic, RGB, CMYK. Okay, that's cyan, magenta, yellow, and what is K? CMYK is a subtractive color model based on the CMY color model used in color printing, and is also used to describe the printing process itself. The abbreviation CMYK, okay, K is key. The CMYK model works by partially or entirely masking colors on a lighter, usually white background. The ink reduces the light. Okay, alright, fine. So CMYK, YIQ, what else do we have? YPP is a scale version of YUV. YUV is here. Okay, let's take a look at that. YUV, also written as YUV, is a color model found in the PAL analog color TV standard. I've never heard this being used before. Is it just really old? color is described as the Y component, luma. A color is described as a Y component, luma. It's described as a Y component, luma. Isn't luma supposed to represent the black and white section? Luma is typically paired with chrominance. Or chrominance. Luma represents the achromatic image. If luma represents the achromatic image, then how is luma... Wait, a color is described as a Y component and two... My god. I should have finished reading the fucking sentence, dude. Okay. A color is described as a Y component, luma, and two chroma components, U and V. The prime symbol denotes that the luma is calculated from gamma-corrected RGB input and that it is different from true luminance. Today, the term YUV is commonly used in the computer industry to describe color spaces that are encoding using YCC. Alright. Okay. Alright. This was a good rabbit hole to go down. And we learned something. Oh, I still want to learn something here. Hold on. Wait, okay. What is YPP? YPP is a scaled version of YUV. It is most commonly seen in its digital form. YCC, used widely in video and image compression schemes such as MPEG and JPEG. Okay. Alright, then we have HSV, also known as HSB, is often used by artists because it is often more natural to think about color in terms of hue and saturation than in terms of additive or subtractive color components. HSV is a transformation of an RGB color space and its components and colorimetry. And its components and colorimetry are relative to the RGB color space from which it was derived. So something that I've noticed with HSV, you start to notice these different things once you mess around with these different color spaces. So like with RGB, it's more about like mixing colors, right? You provide a certain amount of the red color, a certain amount of the green color, a certain amount of the blue color, and then like you mix the three of them to get some kind of color, right? But like you are messing around with individual color channels and you mix those three to come up with something. With HSV, what I've noticed is I believe it's the hue. Yeah, I believe it's the hue that has the... Where can I get a color picker right now? Okay, hold on. Maybe I can see it here. What I was trying to say was that one of these channels contains all of the colors that you're looking for. And then another channel contains, I think it's value. It allows you to basically take like a lighter or a darker shade of that color. It's really interesting. It's a very different way of looking at colors. Where was it? Okay, in these models, colors of each hue are arranged in a radial slice. So usually you don't see it in, okay, no, I'm not going to say usually you don't see it. At least from what I've seen, they're not always presented. Well, okay, maybe they're talking about the way that it's calculated here. Around a central axis of neutral colors, which ranges from black at the bottom to white at the top. That's your value. Yeah, black at the bottom, white at the top. That is your value. So you can then multiply that value from the color that has been chosen. The HSL representation models. The HSL representation models the way different paints mix together to create color. Wait, so hold on. I'm trying to... So we have the HSL cylinder and then the HSV cylinder. HSL kind of seems like HDR, high dynamic range colors. So like as you give it more value, it starts to become more lighter until it eventually becomes white because it can't really display anything more than that. Okay, so saturation is going from white to the actual color, and hue is the actual color itself. Okay. And then value is going from top to bottom. So well, you get to give it like a multiplier between 0 and 1. And so if you go 0, that'll be completely black. But as you start going up, you start to go from like a darker shade of the color all the way to the top, which is like the lightest shade of the color. But yeah, that's my point. Like it's interesting. You get to see different ways of doing things with different color spaces. I found both RGB and HSV to be pretty interesting. I've never worked with HSL before, the lightness thing, or maybe I have and it was just in a different name and I didn't realize it. But yeah, okay, enough with this. Let's get back to what we were doing. Okay, so here we convert the thing from, and this is convenient, right? You can convert the entire frame just with one line of code. And then show the image and then wait for input. Alright, so then in the end we need to release the device and destroy all the windows. Okay, great. Alright, cap.read returns a bool. If the frame is read correctly, it will be true. So you can check at the end of the video. No, you can check for the end of the video by checking this returned value. Okay. Sometimes cap may not have initialized the capture. In this case, this code shows an error. You can check whether it is initialized or not by the method cap.isOpened. If it is true, okay. Otherwise, open it using cap.open. You can also access some of the features of this video using getPropID method, where propID is a number from 0 to 18. Each number denotes a property of the video if it is applicable to the video. Alright, let's take a look at this list of codes, or this list of properties. I think it's this one, right? This is probably going to be an enum. Okay. Yeah, I think I had to look at this at some point to get various things like maybe the size of the video, maybe the frame rate as well. Number of frames in the video file. Okay, cool. Yeah, good. So this is useful information. Also, current position in the current position of the video file in milliseconds. That's a good way to create like for example, a timeline and then displaying the timeline. Saturation of the image, contrast of the image, brightness of the image, hue of the image, gain of the image, exposure, Only for wait, hold on. Can we set this? There's a get property. Is there a set property? Yeah, cap dot set. Just use so and so. Okay, that's interesting. So would that also change the properties of, like, would it change the way that the this is another thing I need to look into. I think I might need to look into this when I'm also reading different codecs. I think it's installed in Linux by default, because like most of the stuff that I did previously, I did it on Linux. And there's like a bunch of things already like installed there for you, like at least from a developer's point of view. So even if there's something that's not installed, then installing it it's just like a line or two of code. So I believe it was installed there. I cannot remember exactly. Okay. Boolean flags indicating whether the image should be converted to RGB. This flag is ignored in case if custom pipeline is used. It's user responsibility to interpret pipeline output. Okay. All right. Okay. Wait, it's supposed to be 0 to 18. Is this 18 items or much more? This seems like a lot more than 18. Well, to be fair, some of these items don't have any description, so like, I don't know. Okay, anyways. Okay, great. So we can use this at some point. Some of these values can be modified using this. Okay, value is the new value you want. Okay, for example, I can check the frame width and height by doing so and so and so and so. It gives me so and so by default, but I want to modify it to so and so. Just use this and this. Okay, great, awesome. If you get an error, make sure your camera is working. Make sure your camera is working fine by using any other camera application. Okay. All right, cool. So we can move on from this, and now we can apply this exact same thing, but to a video instead. Okay, playing video from file. Playing video from file is the same as capturing it from camera. Just change the camera index to a video file name. Also, while displaying the frame, use appropriate time for wait key. If it is too fast, no, if it is too less, the video will be very fast, and if it is too high, the video will be slow. Well, that is how you can display videos in slow motion. 25 milliseconds will be okay in normal cases. All right. Make sure you have a proper version of FFmpeg or GStreamer installed. Sometimes it's a headache to work with video capture, mostly due to wrong installation of FFmpeg. Okay, so we might have a problem here. Let's find out. Let's find out. So we need to set up the whole thing. I can erase a bunch of these things. Okay, CV dot video capture. Okay, Test vid01.mp4. All right. While true, if not cap dot. Actually, would that apply in the case of a video? Cap dot is open. That still applies in the case of a video as well. Okay. Then no cap. Exiting. Wait. Oh, this is a tiny bit different. Okay, we'll follow their logic for now. Because like, as long as basically like the way that this logic is working, as long as there's a frame to read, it's gonna keep reading. But when there's no frame anymore, it's gonna stop. Actually, okay, we can follow our own logic. That's not a problem. So we can then break. But if the thing is open, then ret and frame equals cap dot, what was it, read? Yeah, that returns a tuple, right? Bool and matlag. Okay. So if not ret, then let's say last frame, exiting. Otherwise, we carry on reading, and okay, so at where exactly am I supposed to create the window? Where do I create the window here? Just IM show. I don't specify a window. Okay. All right. cv.im show. Test window 01, and we display frame. What else next? Oh, then we wait for input. If cv.wait key, let's say 25, equals ord q, then break. And then at the end here, we release the capture device, and we also destroy all the windows. All right, we should be good now. Oh, I just realized it's not going to show up on stream. Okay, you know what? Temporarily, I can switch to, or I can switch on, what was it called? Desktop capture. Display capture. Temporarily, I can turn on display capture. Okay. Also, I should fix this issue. Let's just place that properly. Okay. Okay. Right, so let's run this. Okay, so this is a video that's playing. I recorded this video in Paint 3D. And yeah, with that, we have a video being played. And this is great because like it just took a few lines of code, and just like that you have the ability to play a video. Hold up, there's an error. I think it's an error because it hit the end of... Oh, I didn't break. I think that was the problem. Yeah, that might have been the problem. Let's run that back. Let's see if it ends properly. Well, actually, I mean, it's probably gonna exit properly, just without an error this time. Yeah, because there's a break there now, right? So the loop is not gonna carry on anymore. Yep, there you go. Last frame, exiting. Cool, awesome. So now I'm gonna switch back to these two and transition. Okay, awesome. So we know that we have whatever it is that needs to be installed, so that's good. The last thing we need to look into is saving the video. Oh, dude, hold up. So let's do some transformation here. CV dot what was it? CVT color, I think. Yeah, okay. Let's convert the frame. Let's try to flip it. Like, is there an inverting? What happens if I try to make... Well, this is already grayscale, technically. Is there a color inversion thing? Because, like, a color inversion would technically just be... subtracting the maximum value from what the actual value is. So in this case, the maximum value would be 255. So I would be subtracting whatever the value actually is. I would be subtracting that from 255. And that would sort of... I don't know how to explain what would happen. Let's say, okay. So let's say we have a maximum value of 10, right? So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, great. Now let's say our value is 8 and we are trying to get the inverse of this. We are trying to invert this value. Like, we know that the maximum value in this range is 10. So then we can do 10 minus 8 and that gives us 2. So that would then bring us here. Likewise, if it was, let's say, 6, so we can do 10 minus 6, and that gives us 4, and that brings us here. So initially we would have been here, but then we come here. Initially we would have been here, but then we come here. So like, that's when you apply this to colors, you're able to get a sort of, you're able to get like a basically you're able to invert the colors and you're able to get something like um, you know those the negative effect. Back in the day, cameras they used film, and the film had like a if you would look at the film after you had taken the photo, you would see a negative effect, a negative color space. You wouldn't see the actual color from the image. So you get that kind of color when you do like an inversion, when you do like an inverting operation. Now, how do I perform that operation on? Dude, there has to be a better way of doing this, because like NumPy is known for doing operations on arrays more in a more optimized way. So I need to look for a way to apply an operation on every single cell in a multi-dimensional array. Okay, NumPy array arithmetic operations. Where is NumPy's? Okay, this is gonna sound kind of silly. What if I just do this? Would that be accepted? Like, would it apply this to every single item? Actually, I need it to be like this. Okay. Because I don't want to end up getting negative values. Right, let's see if this worked. If it didn't work, then it's probably going to throw an error. Oh yeah, there you go. It worked. It's inverted. So what was black is now white, and what was white is now being drawn in black. And this thing was like kind of lightish, and now it's grayish. All right, cool. So we know that NumPy allows you to perform the operation. And dude, that's kind of cool though. Like, just being able to perform the operation on the entire array without worrying about, like, I didn't even have to iterate over the entire array. This frame is it's a three-dimensional array, and I was able to operate on every single pixel's color by just this one line of code. That's cool. I feel like I'm gonna be using this specific feature later on as well, as I work more with ML related stuff and do more like neural network related stuff. Because like you tend to work with large groups of data when you're doing ML related things. Oh, I don't know how long it's been since I hydrated. So give me a second. Okay. So finally, we're gonna move on to saving a video. So we capture a video and process it frame by frame, and we want to save that video. For images, it's very simple to use I am right. Here, a little more work is required. This time we create a video writer object. We should specify the output file name, Then we should specify the 4cc code, details in the next paragraph. Then number of frames per second and frame size should be passed. And the last one is the is color flag. If it is true, the encoder expects a color frame. Otherwise, it works with a grayscale frame. 4cc is a 4-byte code used to specify the video codec. The list of available codecs can be found in 4cc.org. It is platform dependent. The following codecs work for me. On Windows, DivX. Okay, cool. 4cc code is passed as so-and-so or as so-and-so. All right, okay. Wait, why is there an asterisk next to the string? Anyways, the below code captures from a camera, flips every frame in the vertical direction, and saves a video. All right, so what's going on here? So we create a video writer object. Then we create an out for the video writer. Okay. Oh, wait, no. So the video writer object is called out. Above it is the codec 4cc. Video writer 4cc. Okay. Cap dot is open. Okay, so this is our basic thing, right? Great. Okay, and then we do some operation. And the only thing changing here is that we use out.write and write the frame out to this thing. And then finally we do out.release. So I'm guessing once we release it, that is when it... Actually, no, I don't think that's when it stops recording. I think it stops recording probably here, isn't it? Hold on. Let's create these things. So we do... Actually, wait, this can come here, right? So we do 4cc equals cc dot video capture. I don't know what the thing is called. Hold on. Video writer. Video writer. Why is it not showing up? cv.videowriter underscore 4cc. Okay. 4cc. What does the asterisk mean? I feel like I've seen that before. Python string asterisk. Okay, somebody mentioned this. Oh, yeah, okay. What does it do for parameters? Let's take a look at that. The args will give you... Wait, these are common idioms to allow an arbitrary number of arguments to functions. Oh, shit. I forgot about this, dude. I had read about this. It's args and KW args. KW args is keyword args. I think args is just positional args. Okay, positional arguments. There you go. I mean, if that's the case, do I need to specify, do I need to give like that asterisk? Is this thing defined somewhere? Let me look at the... As I am right, 4cc, okay, okay. Where's the video writer Hold on. Video writer, basic. Video writer, there you go. Wait, is it here? No, this is 4cc. Okay, so video writer. What does the constructor look like? The constructor is expecting... Actually, no, I'm not supposed to be looking at this. I should be looking at 4cc. Okay, so it takes in this. Is there a different... Wait, this is expecting characters. But I can specify it as the first positional argument, and then it takes the entire... How does it know that it's a positional argument? Okay, I guess I can find that out later. Okay, that's fine. That's fine. Either way, what is it? Div x? Is that how I'm supposed to say it? Okay, cool. And then we create the out thing, which is video writer. This takes... Okay, so let's call it test vid02.mp4. And then the 4cc would be our 4cc. FPS would be 25. Frame size would be... I don't know what the frame size is. I think it's 1920 by 1080. Okay, for the sake of this example, let's do 640 by 480. So let's make it small. Is color equals true? Awesome. Great. Okay. So then we... Oh, I'm transforming it here, right? Out equals... What is it? Out dot right, I think? Yeah, it's out dot right. Frame. And then finally, we need to also release out here. Okay. So we're going to run this. Oh, crap. There's a bunch of problems here. Okay. Overload resolution failed. Video writer takes at most 5 arguments and 6 are given. Can't parse frame size. What is the frame size? Hold on. Is that supposed to be a tuple? What am I supposed to look at? I think I'm looking for video writer's constructor. Okay, this is it. The size is frame size. What's the Python equivalent of this? Hold on. Does it mention it here? Input argument doesn't provide sequence protocol. Hold on. What does... Is it expecting a tuple? Okay, maybe it's expecting a tuple. Maybe, yeah, maybe... Wait, what did the example show? Oh, yeah, there it is. The example also showed a tuple. Okay. Cool. I think I can also, like, switch to... display capture temporarily again. And run this. So I'm going to let this play out. And once it ends, then I'm going to take a look at the video file that shows up. Okay, that's the end. Wait, there's also something here. DivX is not supported with codec ID 12 and format MP4. MPEG4. Should I have provided that? Okay, hold on. Let's see what got created here. Okay, there's an ad playing, so I'm gonna hydrate. Hold on. Oh, welcome back. I'm just checking some. Oh, okay. It didn't write anything at all. All right, never mind. So it gave an error. DivX is not supported with codec ID 12. Can I get the codec that it's using? Let me just look at the props again. Where were the props mentioned? Video capture property. Okay. 4-character code of the codec. Okay, maybe I can look at that. So what would that be? Is this accessible from Python? Or do I have to give it like a number? What would it be? Cap prop something, right? Cap prop 4cc. Oh, there it is. cv.capprop 4cc. Okay. So for the time being, oh, okay, this is kind of interesting. How do I provide it? Okay, here's what we can do. So we know that the thing is opening up, right? So what we can do is print out cv dot, no. What are we trying to print out? Okay, cap dot get ID, I think. Get prop ID. No, what are we trying to, is it frame? What is it? What are we getting the thing on? Video capture properties. Video capture. Yeah, it should be on cap, right? Or is it cv.get prop? No. Where is it? It was somewhere here. Cap.get. Oh, it's cap.get. And then in the thing, I have to provide the property ID. So the property ID is going to be cv.cap prop 4cc. And then we can exit. Actually, let's not exit. Does Python have a go-to thing? Does Python have labels? Can I jump directly to the end? Python jump instruction. The equivalent of go-to. Is there a label go-to in Python? No. It is not. Okay. So how do I jump to the end? Oh, you know what I could do? I could just release everything at the top and then exit. Actually, I could have just had this at the bottom then. Right? And then I can run this and exit before it even completes. So this is what I'm looking for. This is the... Wait, really? That's the code? OpenCV fallback to use tag so and so. Wait, what is this? All right, so what am I seeing here? Is this meant to be hex or is it an integer? Reading/writing properties involves many layers. Some unexpected result might happen along this chain. Effective behavior depends from device hardware, device driver, and API backend. Okay, 4-character code of codec. It's a 4-character code. So if one character is considered a byte, what are we looking at here? 1, 2, 3, 4, and then there's an extra 0. I'm kind of confused here. Hold on, let me Google this. cv.cap prop 4cc. Okay, I'm just seeing what answer other people got. Okay, all right. How to get 4 characters so and so. Okay. Oh, wow, you really want me to do that? Okay, all right, fine. Let's do that. Hex int. Okay, so I guess I'll look up. So this is an integer. This is not hex. I'm now looking at the hex, and now I'm going to look at the ASCII table. So let's exit this. And man ASCII. Okay. So in hex, we are looking at 34, 36, 32, 68. Hex. Okay, so that's 4. 2, no, 462 462H. Four six two H. Let me just Google that. Wait, this is actually the codec 462H. Oh fuck, it's H.264. Oh my god, dude. I was wondering why this seemed familiar. All right, so what am I supposed to write here then? Like, is it expecting me to write it in? Okay, let's do H.264. Incorrect library. Oh, all right. There's there's an issue. Failed to load Open H.264 library. Uh, check the environment and or download the library. All right, you know what? So this is where I'm probably gonna have. Wait, fallback to use tags so and so. What if I try ABC1? No, there's still an issue. So I'm gonna need to find out what works for me. Hold on. Windows video codec. Or Windows, let's say default. Right. Okay. So I think I need to find exactly which codec it is that I'm able to use. But I'm not gonna worry about this too much because this is just for the sake of an example. I'm not really trying to write uh I'm not really trying to write to a video. I was able to do this on Linux, but like I said, on Linux you have a bunch of the things installed already, and something that's not installed, you can install it relatively easily. Here, I just need to find out exactly which codec I'm meant to be using. If anything is available already, then I'll try to use that. Okay, that being said, I think that's going to be it for today's stream. Um, I'll finish doing whatever is going on here. And then I need to move on to this section, which is, where is it? Um, where, here. Then I need to move on to this section, which is all the drawing functions. So it teaches you how to draw a line and draw a circle, rectangle, ellipse, and then writing text as well. So I'm gonna move on to this, and then hopefully the next time that I stream, I'm gonna be doing Mediapipe stuff because I need to look into the various um, things that I need to download as well. Because I believe I need to download I think I need to download the model weights that it's going to be using. I think so. Or in whatever way it is presented, I need to download something that the model is then going to be using, which is usually weights. Um, but yeah, that's gonna be it for today. I hope you guys have a nice day, and I will see you all next time. Peace.